Hello everyone. In this video we're gonna start to build the rotator stuff. And just to begin with, I want to send out a virtual high five to a guy who made a community project out of one of his it was meant to be a marketplace project, but it was apparently rejected for some reason. I have downloaded it and I looked at it, and I can only say that it's filled with tons of cool stuff. So if you haven't checked it out, I suggest you definitely should do that. It's this project here called the VR Essentials Kit or something, Essential Kit, by a guy called Jamis. You can see the download here in up here. So if you haven't seen that, I said that. Download it and go check it out. It's really cool and filled with tons of useful stuff. Just to give it a brief overview of what it does, you will have doors and drawers and levers and turnable stuff, and basically a lot of really cool features that you can use in VR contexts. You also have something like slots and keys and all that, but that's something I haven't tried to implement yet. I have a kind of a different idea how I want to approach something like that. And actually what I wanted to say with this is also that it's once you open up something like that, it's a cool thing that because you can see how other people attack this thing and see if you like it or not, and you can draw inspiration from it. So I really think this is a top-notch idea to do that. So James, a high five, virtual high five for you. Great stuff you put in here. Right, so let's get back to building the stuff. So I'm just gonna find my project because it actually got lost. Let me just pick it from the other screen here. Okay. Okay. I guess, yes. All right. Hang on a sec. Okay, it's opening now. So the way I decided to do the rotator is a little bit different from what Jamis did, and you will see it's a different, basically a quite different implementation. At least the first one I'm gonna do, and after I'm done with this one, I actually think I'm gonna try and recreate what he did, just in my own way. So we will have two different behaviors for rotator, because what I mean by this is, is that you can, if you have a controller, depending on what type of control you have, you can turn things, like move your controller around like this physically, and like imagine you have something like I don't know what you call it. In Danish you would call it a drejehjul. That was a Danish word for today. I don't know what you call it really, honestly. But consider this motion here. You're moving your controller like this. But you can also turn things like a screw, kind of. And those two things are pretty different, and you can totally implement them in different ways. So I'm gonna show actually two ways of doing that. And I'm gonna start off with the screw one, where you kind of turn like that. And the reason for that is because it's very similar to how we did our implementation with the slider. So it's just more convenient, and the next step, it's just going to be more natural. So let's get to it. Right. So we have the BP mover, that is our master object or the base object. Then we have the physical mover, and then we have the physical slider. And then on top of that, we also have the physical track bar, which is replaceable. So it's not going to be a slider because it's going to rotate. So it's going to be a physical move because it's going to be based off physics, also this one. So I'm going to right click and create a blueprint class based off this one. So physical rotator. Physical rotator. Okay. So I am just going to steal some basic stuff from the physical slider because there's no real reason to do too much work if you can just copy paste stuff. So we have, for example, we know we have something going, actually quite a bit stuff going on inside the construction script, like we're setting some damping stuff. So I'm just going to copy some stuff from in here just so I have an idea what we're supposed to do. So let me copy everything from the construction script. I'm just going to copy in so I have an idea what I'm about to do. Like this. Okay. So first of all, we have the damping, and the damping is setting the value for the linear damping, and this is a rotator, so it's not gonna, we're gonna get back to that, but we're not, for now we're not gonna set the linear damping. It's gonna be more natural to say set a angular damping, so set angular damping equals to this one instead. So for now let's just get rid of that. I promise we'll get back to this because there's a little catch to this one. So if it has limits, then we're gonna do something with the limits. So the limits for a rotator is gonna be a little bit different. And now that I look at this, we could totally do something different here. Let's make a small modification to this because I just realized this is a silly way of doing it. We're gonna do a select here instead. And then we're going to take the has limit and plug it in here. So if it does have a limit, and notice this is false and true, and normally things are true and false, but just be aware of that because that was kind of throwing me off the first time I used this one. Has limit, if it has limit, then we want to set it to true, limited, and if it's false, then we want to set it to free. And then we can always just pass in this guy here, and that means that we can get rid of this branch and not this one. We can get rid of this one and just plug in this one. So personally, I just like this a little bit better because it looks more compact. Okay. But well, we're not setting the X limit, by the way, so that was kind of silly. But in order for this not to go to waste, we're just gonna paste that into the physical slider. That way, that wasn't done in vain, like that. Okay, so instead of setting the linear, excuse me, the linear X limit, we're gonna drag out and set angular something. Swing 1 limit, which corresponds to the first axis there. I don't know actually which axis. I believe it's the x-axis. I'm not sure. Okay, but anyway. Oh, this one. Convert? No. Motion type. Select. Okay, so this is apparently different. Oh, yeah, okay. So free, limited, or and free, like this. So I hope I'm getting this right. Let me just check with some notes I have over here. I'm not forgetting something. This was our constructor. Okay, so we're setting this. Yes, that's cool. All right. So on the, if we go back to the physical slide and see what we have in here, we have a lot of stuff going on begin play also. So if we go back, let me see, did we get, okay, we didn't do the ghost mesh stuff yet, but in order to do that, we need to have a helper function ready for that, because it's not so easy actually. It's quite a mathematical thing we need to do first before we can do this part here. So I'm just gonna do this comment and say to do. And then, so we're gonna just skip that for now and move on to begin play. Actually, let's just get rid of that because we're gonna copy everything in anyway. Okay, so the next thing we need to do is to set the, apparently the physics constraint reference pose position, and then we need to set the world position. In this case, it's gonna be a transform. Getting back to this part also. So let's get rid of this part here and set reference frame. So you can see we have a reference frame, which is a transform. So it's both orientation and position. But in this case, we're only going to set the orientation. Orientation, yes. So here is the funny thing here. We're setting it for frame 2 again because it's we set it on component 2. It takes in a primary and secondary axis. So we only have a limit here. So just right off the bat, it looks like we're missing something, and indeed we are. So hang on a sec. Am I doing this correct? Yes, I am doing this correct. Okay, because the cool thing, a rotator has 360 degrees, so that's a full turn. But we can turn more than 360 degrees, so we cannot just work from the assumption that it's going to be one turn only that we will allow. Or you could do if you wanted to make things simpler, but that's not what we're going to do. So we're going to throw this stuff here out, and then we're going to say divide. There's a division, whole, and remainder, which is very handy for this stuff here. So we can fill in the divisor by 360 degrees, which is going to give us a remainder. So assuming the limit is under 360 degrees, then it's going to be the same value that we get back in the remainder here. The return value here, which is an integer, is going to give us the whole number. So if you have like 400 in the limit, then you're going to get 40 here, and then you get 1 here. So that's the way it works. Okay, so what we need to do with this is to multiply this by our the same. If we recall from the way the reference pose works, I deleted it now, but you know, we multiply it by minus 0.5, so we move it half a turn back, because the rotator has the same thing, it goes both ways. So when you set the constraint on angles, so we need to return this half the limit like that, and then we need to make a rotator. And this we want to feed into the yaw. This part here, I have a bit of a hard time to explain. I am probably not the best one to do that. Whoops, why did I do that? I'm probably not the best one to do that, but and therefore I'm going to skip that. Just assume that this is the way we do it, and I can only say that I did quite a bit of experimentation to get this right, And then I was peeking in James's example, and I said, "Oh my God, that is why." And he's doing the same thing. Cool. I am just gonna assume that it's working, and that's the way it works. So the primary axis and the secondary axis is what we get out. I'm not going to pretend I know what these two are. So we're just going to drag out and say get forward vector and drag out again and then get the right vector. So I suppose this is something to do with the way it's going to calculate the constraint axis or something. So that we have a forward and a right, and then those two vectors give us a plane, and then we can find the orthogonal cross product between these two, and then we have something. Yes, probably something about that. Okay, so that was that stuff. Okay, so we should also do some other stuff here. We have the rotation stuff being said here. We're going to do that on a separate section down here, and somewhere down here, maybe somewhere down here. Yeah, because we also should define a few things, because we have a limit, and the way we're going to set this up is that we're going to deal with an angle and figure out how things rotate, and the limit or the value can go beyond 360. So I'm going to keep track of the current angle also. So we're going to add in a float here, which we're going to call angle. And 0 to 360 based angle, like this. And we're going to plug that into the internal area here. So the angle can actually be derived from this same here part here. So we're going to take the value instead this time here and plug into the dividend, and that's going to give us our angle. So set the angle, and we can also set the round, because this is going to be every time this turns, it's going to be one round. So promote that to a variable, call that round. Number of rounds. Can't really come up with a better name or description. And the internal as well. So these two values we are going to set here. And that's just going to be convenient, so we don't so we have something to start out with. Yeah. Okay. We're going to need a last angle also, and it's going to be clear in a moment why. I'm not going to do it right now, but we're going to return to it. But just remember I mentioned it. Okay. So here comes the funky part, and I probably need to peek on my notes on the other screen once in a while, because I don't want to get this math part here wrong. Okay. So the thing is, we want to set not a location for a static mesh component. We want to set a transform. And by that, we could simplify things. And actually, I think if you look at this example here, the VR Essentials kit, you'll see that it is using a slightly simplified version by only setting the I think it's the rotation only, somewhere in here. He's only dealing with rotations, and that's perfectly fine. I decided to make things a little bit hard on myself for some reason. I don't know why I enjoy that, but I decided to go with things. Okay, fuck it, I'm gonna do the transform instead, because that's probably gonna mean that I can put things wherever I want them to. So that's what I did. and it took me quite a while to figure out, but I did in the end. So we're gonna set a transform. What is it? World transform. That was actually what I wanted to get to. And in order to set a world transform based off a angle, that is basically what we need to do. We want to get in a angle, and we do have an angle now because we derived it here up from the value. So we want to figure out how to set an angle, and in order to do that, we need to figure out what is our what is the beginning. How is it, how is it relative to our current actor right now at the beginning? And the thing is, the static mesh component is actually simulating physics, so that will be relative to the world, which sucks. But luckily for us, we can figure out that relation by saving a start transform. So on begin play up here, we can save that initial transform of the static mesh before we modify anything. I think I did that here. Let me just check. Yeah, correct. So we start off by get world transform, and then we promote that to a variable and call that start transform. Whoops. Okay. Hope you're with me still. So this is the initial location before we do anything with it. So right now it's in here, and if we were to rotate it, for example, in the editor, let's say like this, then that would be the transform that we would get out. I mean, in the world, of course, wherever it is in the world, which it is not right now, but when it will be. So that's a transform that we're saving here, there. Okay, so we can get the the relative. Let me comment that initial of the static mesh component. So we need to figure out the relative transform between these two. We can do that by using this convert transform to relative. So if this guy here wasn't a static physics mesh, then we would just get type in, drag it out, and say type get relative transform. That would be all we needed to do. But since it's not, then we need to do this trick here. So that's just a little thing to note about this. So in order to get the angle here, we need to convert this. So this is a relative transform right now. So we want to convert this into a world transform, or world transform. Yeah, so this is local. Yeah. Okay, so here's why this guy here was throwing me off, because I thought it would be that this was the world, the local transform, but I'm pretty sure it isn't. So we will compose this transform with the angle that we want. I mean, what we want to set it to or add to this angle here. So we're gonna make a transform. Make transform, and we're gonna break the rotation, and then we're gonna plug in the angle into the yaw. So what we have now is a weld transform, I suppose. But it's a weld transform in the local space of this relationship between these two guys here. So we are not done yet. We need to convert this back again into relative weld space relative to the actor again. So we need to get this back again. So we need a little more space for this. So we need to get the actor transform up here. And the thing is, we want to add this into the local space of the transform, the actor, because otherwise it's going to be in the weld. And if you rotate it in a different angle or weird angle, which will probably be the case if it's a game, it's not going to line up perfectly facing the same direction always. You're going to want to be able to put things at random rotations. So you need to add this angle into the relative space of the actor. So therefore we need to invert this first. Then we need to compose this transform with this, which is right now a weld, funny weld vector transform, but at in the local space, relative space between these two. So we need to invert this and this one as well. And now we have a transform that is, I should probably comment this, but I tried a few times, and every time I do it, I just end up confusing myself more. So I just end up reading it. And then finally, we need to convert this into weld, a weld transform. So invert transform. That should be all. So that was super easy, right? Nope, I don't think so. So we're definitely going to do this and collapse to a function and call this a get transform from angle. Make it pure, so it's just a little bit better to see. Look at. So that was basically what we ended up with. And we need to execute this as well. So I'm going to insert one of my trusty sequences here. Just like them because they make it easier to organize things. Okay. Compile, save, nothing is crashing. So basically what we could do finally here is to go back to our construction script where I made this to do, and we can delete this one and drag out and set weld transform. So this is not going to be the limit like this. It's going to be the limit device division 360. I think I have this value somewhere already, but might do actually. I'm just going to do it anyway. We can always optimize things afterwards, like that. And here we have the value which we're going to get, and kind of the same deal. The value can also be greater than 360, so plug that in between. What did I do? I think I jumped into the function. Like that. The ghost genital mesh. I just read it as that. That was so funny. Right. I think that's it. Oh, we need to call it as well. Like that. So we should have something, hopefully. So if we set the physical rotation. This is, by the way, not the guy that we want to put in the level. Why do we have something down here? The thing is not working. I did something wrong. Okay, we're gonna figure that out. Let's set a limit of 90 degrees. Something happened, but it happened at the wrong place. So it's happening all the way down here on the ground. Something is happening. So we got something wrong somewhere. It's probably inside here. Get actually transform. I think I did everything correct. Invert this one. Yeah, I do that as well, and I invert that one, and then I don't see anything wrong with that. We set that here. Get the world transform. That is. Oh, wait a minute. Oh, yeah, of course. The construction script. The construction script runs that stuff first, so obviously something is gonna screw up. This one needs to be set first. There we go. Now we see something. Yay! Oh, you can't really see it, but let me turn it 55 degrees. Now we can see where it is. So we're getting there. This is really a big success. So if I were to select this one here, and oh my god, move it, for example, out here and compile. Then we're gonna see that the red one, oh fuck, I forgot to rotate the red one. The red one is of course gonna start out there as well. Because we could get away with that shortcut with the slider because they don't move like that. But for this one, we actually need to do where is it? This one. Let's just plug it. Whoops. Plug it in here, there, and it's not the ghost mesh. It's gonna be or the ghost min mesh. It's gonna be the, yeah, it is the ghost min. Sorry, ghost min mesh. This one. Hallelujah! Now it's here, on top of it. So if I were to set this to, let's say 200 something, it's gonna jump down there, and we are gonna set a beginning value of 50 degrees. Then we can see where it moves, kind of where it's supposed to move. And the center is here, it seems. So it's gonna rotate. Okay, you can't see my screen, but it's gonna rotate that way probably. If I were to set this to 100, it would be a little bit more clear. You can see it's gonna move that way. Can't really decide if this is a bad idea to have these ghost meshes, but when I made them, it seemed like a really good idea. Anyway, that was a little bit. That was a lot. So I hope you guys are with me still. We're gonna actually do something, because right now we're just creating the beginning of it. But this mofo of a function that get transformed from angle, this guy is gonna be super central to everything we're gonna do from here on. And yeah, because we're gonna fall back on using this all the time. So, By the way, if you haven't seen my video on rotations, let me just see if I can find that. I have another video I dedicated to to UE4 location, rotations, and transforms. And you can find it here. So in that video, I talk a little bit about how to go between different spaces and do rotations and transforms. And in particular, a little bit more about this conversion stuff between two relative transforms and switching, adding things in between them, and so on. So that is maybe going to be useful if you don't understand much of what I just said. Right. So let's continue in the next video and build something, continue building actually, because for now we just started. We have a bunch of stuff just floating around out here still, which I forgot to connect again. How does this even work, by the way? Oh, the angle is being set here. Okay, I don't understand how that worked. Oh, it's because it's going to rotate several times. Okay, great. Just having a chat with myself. We're going to continue in the next video and work our way through some of these things all the way and build most of the same logic that we did with the slider. And once we have something going and it's working, then we're going to try and implement the Jamis version of this version here, basically. So stay tuned and